Okay, so study session, AP Physics, October. Okay, projectile motion. We're going to give this all a shot today with the camera and recording. Okay? So first deal, let's make sure you guys can just do a simple thing. You know, you got a cliff and you got an object, I don't know, a marble. You're rolling off a lab table. So the lab table has a height of, let's say, 85 centimeters. Okay? And the marble rolls off the table with, an initial velocity. Oh, what is this initial velocity, folks?
A mile an hour.
Not a mile an hour.
Second.
Come on.
12 meters per second.
12 meters per second? Sure, why
Really
not?
fast.
12 meters per second. So B, what direction is this initial velocity? Is it in the X, the Y? Is it the tangent velocity?
Yeah.
X velocity. So this is Vx naught. Now what are we supposed to know about Vx naught?
It equals to cosine.
Well, is there an angle?
No.
No. This time around, it's just coming right off Vx naught. What else do you know about Vx? Something you're supposed to know.
Gravity doesn't affect it.
Gravity doesn't affect it? No. Gravity affects it to make what? The velocity is always constant. So the initial and final velocity in the x direction, okay, they're equal. Okay, and that's going to help us later if we want to find out a couple things. First of all, determine how far it will land from the base. So we want to find this delta x over here. How far is it going to land with 12 meters per second? Okay? Second, what is the final velocity, both Vy and V final? So what's the first thing to tackle?
Time it takes to fall.
Yeah.
Yeah, so all three vectors are going to have the same velocity when they fall. So we want to tackle is that falling time. So what is Vy initial equal to?
85. Wait.
The very initial, what is it right here at the very top?
VYO.
Yeah, it's 0.
Oh, what am I
Oh, I
thinking?
see.
So to deal with the first problem, you have y final equals y initial, Vy naught times t plus 1/2 gt squared. So guess what? That guy is 0. What else do you know about the initial velocity, the initial distance? What are you supposed to do?
0. It's 0.
Make it 0. So you're going to put an x-axis or a coordinate axis, and that's 0. So that means this guy is negative. That change, or that final distance. Okay? So we can solve for t, the time that it's all going to fall at. So t delta y over g square root. So now you can determine the how long it takes to fall. So 2 times, let's change that to meters, 0.85 meters. Or you change gravity to negative 980 centimeters if you're going to keep the centimeters. Okay. And going to need a calculator. I don't know what the answer is. Do you guys know what the answer is? Yep, and I'm going to go, yeah, and I like the idea of going at least one digit more than the sig figs, because the answer in the end is what we're going to put to the sig figs. Is that cool? Seconds. So now we know how long it's going to take to fall. So how are you going to determine the distance?
You plug the time into the blade equation.
Yeah, so you could take this same kinematic equation, but now it's Vx naught times t, and then since in the x direction there is no acceleration because the acceleration is always in the y direction due to g, this guy is 0, okay? And so delta x equals Vx naught t, and then you could just plug in your values. So it's going to be 12 meters per second times 0.416 seconds. 4.99 meters. Is that what you got? So this rounds up to 5.0 meters. Is that what you guys got?
I'm still trying to figure out how you got 0.416.
Okay, so we solved for time, rearranged this math to get 2 delta y, bringing that one over g. So this is the 1/2 being reciprocal. And then we plug in our values, the negative 85, but it's 0.85 meters because I kept this in meters, unless I make this 980, and then keep this centimeters, we'll get the same number. So you plug this into the calculator because all 3 vectors, again to review, all 3 vectors share the same time. That's something that you can always rely on. Then you plug it in, you're going to find the distance. So at least now we have the distance. The trick now is, what is the final velocity when this object, this marble, hits down here, so Vy final. Because do we know this one? Vyx final?
Yeah.
What is it?
12 meters.
The 12 meters. So this is 12 meters per second. So now we can find our tangent velocity using component vectors, right? We just take this vector that's over here and bring it down here, and now we can find our velocity in the r, the resultant velocity. So how are we going to find the final velocity? And is it okay if I erase this?
Yeah.
Okay, so how are you going to find that final velocity? So there are equations you guys are supposed to memorize.
The other supposed to start with the Vf squared equals
Yep.
Vi.
There you go. So Vyf squared equals Vy naught squared plus 2g delta y. The cool thing is we know what that one is.
0.
0. Okay? And so all it's going to come out to be is Vy square root 2g delta y square root negative 980 meters per second squared and negative 0.85 meters. So if somebody could punch that in, we can determine that. Did somebody get it already?
4.08.
4.08?
Yeah.
4.08 meters per second. And everybody's in agreement? So the cool thing, now we can find the resultant distance, or not distance, velocity, VR, because it's equal to V x final squared plus Vy final squared, Pythagorean theorem. Because it's tail, head, resultant vector. Square root. And so now we're going to go 12 meters per second squared, 4.08 meters per second squared, square root. So far good? So would anybody get an answer, please? Nobody got an answer?
12.7.
12.7? Okay. 12.7 meters per second. Only one problem. We're good to 2 sig figs, so 13 meters per second. So let's up the ante. So somebody said, hey, somebody decided to use an angle, so let's use an angle. Like, I don't know, 35 degrees. And determine everything else just the same.
It is the same speed.
You want to use the same speed?
Sure.
Okay, so marble doesn't roll. Marble is shot at an angle of 35 degrees with an initial velocity of this, but is this now Vx?
No, it's VR.
No, it's no longer Vx. It's V naught. It's the tangent velocity. It's not Vx. Make sure you get that. So it's not Vx. It's V naught. Now we get a whole different deal. This no longer applies. We can still do all the same math, but it's going to take into account the angle. And understand, on an AP question, I might not use any numbers. I could put D or H in here, and you solve it in terms of the variable. Does that make sense? They do that. Those folks like to do it a lot. So in this case, we can do all the same thing, but in this case it's going to go probably somewhere down here. So what are you going to do?
Max height equation?
What?
Isn't that like a equation for max height?
Ooh, you're gonna get tempted for the range equation, aren't you? Or max height and all that. The question is, I could ask for max height and you could figure that out later, but actually determine how far it's going to land. What do you need? What do all the vectors share? What do all the 3 vectors share? Time. So what's going to happen is this thing is going to go up, 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 up. At the apex, we're only going to have the vertical velocity, nothing at the x. And then all of a sudden, all the velocities are going to happen, right? So what we need is time. So do the same thing. Y final equals y initial plus Vy naught t plus 1/2 gt squared. This time that is not 0. This is not 0. That's the whole deal. That's not going to be 0. This one can be 0. But this guy is going to be negative 0.85 meters. So, here's what's going to happen. This guy is 0, so 0 equals 1/2 gt squared plus v naught sine theta. We need to use trig times t. We're using this y component plus negative, okay, y final, because this one's 0. Or I could put the minus here. Let me put the minus here. Y final. I'll do it like that. That way it's less confusing. So like that. So now we got to plug in everything. Because this is going to be what type of equation?
Quadratic.
Quadratic. You're going to have to use a quadratic equation to find time. So this guy, math-wise, is going to be negative 4.90 meters per second squared, t squared, plus we're going to have the velocity, which is 12 meters per second, sine 35 degrees, t, minus 0.85 meters. So I'm going to get rid of the units so that I can do this better. So 0 equals negative 4.9 t plus, I don't know what that is. Make sure, let's get that thing. 12 times sine 35. Come on, 6.883 t plus 0.85 meters. Oh, no meters, I'm going to get rid of the units. Okay, now you can do the quadratic equation. T equals negative 6.883 plus or minus square root 6.883 squared minus 4 minus 4.9 times 0.85, and then 2 times negative 4.9. Yeah.
1.52 seconds.
That's the positive value. So the one of the t's is positive what?
1.52 seconds.
52 seconds. Do you know what the negative one is?
Negative 0.114.
Negative point?
Yeah,
1, 1?
114.
Or 114. Okay, so that negative really, that's the time if it took off from the ground on this side, if it could. That would be the rest of the parabola. Is that cool or what? But we're not going to use that. And so now you can do delta x, just like the other one. So the other problem, delta x equals Vx naught t. What do you know about Vx naught?
It's 12 meters. Or no, it's not 12 meters per second.
What?
There's
Be careful. It's a trig problem. See, don't make that mistake. It's a trig problem. T. So now, the 12 meters per second, cosine the 35 degrees, take the time, 1.52 seconds. Okay? And that's going to give us, I don't know what, but let's get it. So 12 times cosine 35 times 1.52 and 14.9 meters per second, or approximately 15 meters per second. Is that what you guys got? Yes? No? Did you try it? Okay. So that now we answer the first question. We know how far it's landing from the base. About 15 meters. Wait, what did I put meters per second? Delta X. This is meters, guys. Did anybody stop me? Meters. What the J? It's meters. It's a distance. Determine the distance. The second half wants velocity. So now we know how far it goes. We know t. T is 1.52 seconds. So now, what is the final velocity both for the x and the y and the final? So, can I erase this? Yes?
Yeah.
Okay, I'm going to erase it. So how are you going to find the final velocity? Well, first, what's the final velocity in the x direction? What is Vx final?
Velocity cosine theta, which is...
Yep, that's it. That one's straightforward. Velocity cosine theta, 35 degrees. Okay, and I don't know that one because I just only plugged it in with the time. So 9.83 meters per second. Okay, so that's our velocity. Okay. So how are we going to find the y? How are we going to find the y? Oh, no clue?
I don't suppose it's the same way with the sine, is it?
What?
I suppose it's the same way with the sine now, is it?
Well, what do we do?
Oh, wait.
It's like before with the VF squared equals.
Okay, so
Oh,
why
really?
are we afraid to use it? Let's just try it. Let's do it. So if I do Vy final squared equals V naught y squared plus 2g delta y. Okay, let's see. Oh, what is Vy?
Oh, velocity sine theta.
Yep, do not forget to do this. This is where I have folks really screw it up, is they forget to change that Vy. They get so used to the horizontal one making it 0. It's not 0 this time. It's blasting off with this velocity right here, this 12 meters per second. So we're going to have to account for that. And delta y, and I'm going to square root this, because then that's Vy final. Okay? That's how we're going to get our Vy final. So now we have the x, we have Vy final. Okay? So 12 meters per second sine theta square plus 2 times negative 9.80 meters per second squared, 0.85 meters, and we square root this whole thing. We should get a velocity. I left some steps out myself. Ooch. I forgot that. Times -5. I'm trying not to lose my parentheses. What'd you guys get? Oh, you guys are taking a while too. I just didn't want to lose my order of operation. What'd you get? Oh, you didn't do it? What'd you get?
Probably not the right answer, 780.
What'd you get? Just say it.
780.
No, that's too much. That's crazy.
Did you square root it off?
I got 8.
Oh,
Flat 8.
Yeah, 8.00.
I'd say about like 20.
Yeah, 0.2. Yeah, 8.00 meters per second. So what we're finding here is we got the Vx final, we have the Vxy, and now we can find our tangent velocity. Okay? And this time around we could also determine the angle that it's going to hit the ground. So let me do this in a different color. I'm going to do it in black, hopefully it'll show up. So VR is going to be the square root of Vx final squared plus Vy final squared. So now we can plug in the 12 meters per second, square it, plus our 8.00 meters per second,
Wait.
square that.
Isn't the Vx final 9.83?
Oh, sorry, oops, thank you. 9.83 meters per second. Not paying attention, see, so don't screw up like that on the test. Make sure you take into account all the velocities. And we should have our V resultant or V final. So 9.83 squared plus 8 squared equals 12.7 meters per second. Oops, approximately, wait a minute. 13 meters per second. Isn't that familiar to the last problem? Almost? Just slightly off, yeah. Hey, ooh, what angle is it going to hit the ground?
Oh, yeah.
What?
Yeah.
Well, here's the deal.
Would it just be
Guys and gals,
55?
make sure you can make it go all, from here's 0, make sure you go it all the way around. So in this case, it's going to be what? It's going to be plus. So it's going to be plus the 270 degrees, plus what? Tan, arctan, 8.00 over 9.83, and that should give us our angle all the way around. Okay, so remember, we're going to take it all the way from here, so that we can, people will know what angle we're talking about. So hopefully I did it right. Plus tan 8 divided 9.83. Oh, it's barely nothing. Did you guys do it? It's barely nothing. I did it. Did you guys, nobody did it?
I got 312.
You got 312?
Yeah.
I think you had 300. Oh, wait.
Don't forget to add the 270 too.
No. I know what I did wrong. Silly person. I need to do my shift. I got 309. Did you do 8 divide by?
Yeah.
And it's 8.3, right?
Yeah.
9.83. Yeah, I got 309, which sounds reasonable.
Oh yeah, I think 273 is 270 for some reason.
Ah,
Yeah,
okay.
that's fine.
Thank you. 309 degrees. So we're taking it all the way from the 0 all the way around. That way we know for sure what angle we're talking about. Is that cool? Because then you would have to say the negative of this direction from the horizontal, or something like that. This way we know for sure where it's going. Is that good? Okay. So we did the whole thing. Can we use the range equation with this?
Apparently not.
No, because it's elevated.
It's elevated, or even if it was
Under.
depressed. So let's say, could you guys do a problem where it's depressed? How about this one? Could you do a problem? This gets so exciting. The problem is I don't have any good velocity or angle right now in my head for this. But could you do something that's like this? Oops. And determine where it hits the wall.
Well, that's pretty intense.
Or if it makes it over a wall. How would you handle this one?
Same way the other one is.
Just handle it the same. Look. So handle this the same. Make this your 0. So why not is 0? And whatever, if it goes all the way here, this is YF. You could do that, or this is YF to determine that height. I would have to give you a distance. I would have to give you this distance. I would have to give you delta x. Because that way you can find the time it takes to get to that point. Okay? Do I have one in my head that we can use?
13.
So let's make this, I'm going to make this up and we'll see if it works. I could screw up. But let's say this wall is 300 meters up. And that wall is 300 meters up. So let's make this delta x. I'm making this up so I don't know what to put. Let's say this delta x is 25 meters. Oh, and I'm going to put a period. Let's do this. Make this 4 sig fig so that no, we end up with 2 sig. I don't know what a good theta is.
25.
25?
Let's use 25.
Okay, and let's make this 5.0 meters, this height. So this gets interesting. So you're going to determine where it's going to hit this 300 meter wall. So what do you need to do first?
Find the time for time.
Okay, so theta is 25 degrees, so theta is 25 degrees, and we need to find the time. So what's a good speed to start with? What's the initial?
30.
We're all making this up, so we don't know what the jig's going to happen.
30 meters
30
per
per
second.
second.
30?
30
Yeah.
meters per second.
30 meters per second? I find it high, but okay, let's do it. Wait. 30.0 meters per second. Okay, this is what you guys decided, 30 point. So let's give it a shot. Let's see if this is gonna hit the wall or even go above the wall. I don't know. It might even hit this corner and screw up.
That'd be kind of disappointing.
That would be disappointing. Well, let's find out. I don't know. You're the one that suggested 25. We could have used 50.
Yeah.
Yeah, but what's the risk of using?
Okay, let's take 25. Let's see if it's going to work. What's the risk? Yeah, no risk. Okay, so what do we need first?
Time.
Time. So can we use the y? Can't use the range equation. I know you guys are all tempted to do this. Delta x equals v naught squared sine theta 2 theta over g, and g is negative. Can't use that.
So we can only use the range equation when it's on the same level.
Only on the same level. So guess what? The range equation can only be when y naught and y final are equal to 0 on the same level. Okay? So that's the only time you can use the range equation. So this one, guess what? Do you not have the distance?
Yes.
Okay. Do you not have the initial velocity?
Yes.
Can you solve for time?
Yes.
Yes. Just don't make this one mistake. What mistake can you not make?
That one.
This one. Vx naught, because there's an angle, we need to take into account the component vector in the x direction. So v naught cosine theta. So 25 meters, 30.0 meters per second. This is going to get entertaining. And cosine 25 degrees. Well, let's see what we get. This is going to get entertaining. Okay, so 25, 30, cosine 25, enter. I got 0.9195 seconds. I'm going to go a little further. Okay, let's see how far this is going to get us. So, let's do this in another color so that our guests outside can see this. So, y final, y initial. So we're going to make this guy 0. So that means this thing is really, what height?
305.
305. So we're going to have to do some funny subtraction later on, huh? So Vy naught t plus 1/2 gt squared. Be careful of this guy. So this is Vy naught sine theta t plus 1/2 gt squared. So 30 meters per second. Sine 25 degrees. Let's hope it doesn't hit the wall. 0.9195 seconds. Plus 1/2 negative 9.80 meters per second squared. Okay, and this is going to be a tight squeeze for the camera, so let me make sure I can put this in. Okay. Don't forget to get that negative in there. That's where people are going to foul up. Oops, I forgot to square it. I forgot to square the time. Hey, it's not too bad. What'd you guys get?
7.51 for Jim.
Yeah. Or 7.5 meters, yeah. So 75.2 meters. So that means this height is actually what? Yeah, 2.5.
Oh.
2 meters, so it hits it right here. So I didn't need to make such a big wall, I can make the wall a little smaller.
Yeah. I kept the y initial in there. I just put as -5.
Did you put -5 and did you get the
Yeah.
point 2?
Yeah, I just got the same.
Oh, so we could have done that?
Yeah.
Oh, so wait a minute. I decided to make this 0.
Oh, you made that 0, okay.
Yeah,
So then your answer would be 7.5 too.
yeah, so my answer's 7.5, but that's not the actual answer because I gotta subtract this 5 point, because it's above. So you launched it, it does hit the wall. So I just didn't know how high to make the wall, so I decided to make 300 meters because I can guarantee I'm gonna hit the wall. So I could just make this a 10-meter wall, which is reasonable. Right?
Yeah.
But we could increase the angle. So that's so far pretty good. You guys are good with that?
Well, increasing the angle, like, I guess it's like not really that much of a reason to do it because there isn't a measurement between, like, there isn't a measurement where the step up 5 meters happens. So I guess the angle, it could stay at
Well,
5.
but one thing that's for sure, you can get maximum distance with which angle?
45.
45 degrees. So what if we were to change this 45 degrees? Now,
Might go
the
lower.
problem is we need to change what?
Oh,
That 45 degrees.
Actually do this.
And that's going to change our time. Is it going to make our time less or more?
More.
Yeah,
Are
more.
we trying to
It's
get it
gonna
to go
go
over
higher, it's
45?
gonna-
Yeah, let's see if it goes over the wall.
It's gonna be more.
But wouldn't 45 not be like the most efficient thing because we're not actually like trying to go as
It
far?
makes it go further, so that means it's going to
45
go
is the
down here
maximum
further.
distance.
So that would change the apex, but will it go beyond?
No, maximum distance.
It depends on where the apex of the height is.
Right, see, it'll change the apex. What it will happen is the apex will be up a little higher, but will it be high enough that, is it high enough that it brings it here? Or is it high enough that it just hits the top of it?
Well, what Logan's asking is,
Like, what would be the best angle to get it as close or above the wall itself?
Well, the thing is,
Like, is there a way to tell?
45 degrees is our maximum distance.
but it's
Well,
not
yeah.
the maximum height. is
Yeah,
what
it's
he's
not
saying.
maximum height.
The maximum, but the problem is the maximum height might bring us in. So we might as well see how far it can go out.
Well, he's
And
what's
if
asking
it-
is
if
if you can calculate.
Yeah, but
what
see,
would
the
be
thing is
ma-
that,
what would be the best one for height, because we know the best one for distance.
yeah, but the problem is if we go too high, we'll be definitely down here
Well-
rather than its base.
Yeah, but he's,
And if we go too low, we're still gonna hit.
Well, a better question would be, is there an equation to like figure out what's the best, I guess, arc to get it over that?
Well, not in this case, we're gonna have to play with this because we're gonna make it 15 meters instead. Right?
so
Because
would-
it's hitting it. So I would go with the 45 to see how far out it goes before I would determine the angle. That's my thought. Because I don't have, then you're going to have to derive an equation for the max height. And the only thing the max height's going to give you is where it's going to be somewhere in here. And then you could shoot 90 degrees, not 90, 89 degrees. And that will give you max height. I'm just going to, a maximum height. But guess what? It's going to be like right here.
yeah, like, just what Logan was asking was.
So I would go with 45,
like,
yeah.
essentially, because we're firing at 30 meters per second, which is a pretty, like, intense velocity,
Semi. Guns shoot more than that.
Since the wall's so close, he's kind of asking, if like, this is the wall, and then this is where we fired it from, 45 would go like this, but if we fire it like, I don't know, maybe like 65, we go higher, end up landing closer to the wall, but he's asking like,
Make it
since
over,
that's
yeah.
a higher height is what, that's what the question
That's a
is.
good way of explaining it, thanks.
Right, I know. But so the problem is I don't know which one we'll do. I don't know what.
Well, what I was asking is if there was a way to know that other than guessing and checking.
The only other thing you could do is try to figure what is the best angle here and distance here. So now you want to figure out how far out. So And yeah, again, I end up with 45 degrees. 45 degrees gives me the longest length. Will the 45 degrees make it pass? So I would end up doing this, stick my time, that new time here, and see if this goes beyond 10 meters.
Alright, let me check it real quick.
Yeah, because you still need to know whether you're gonna make it past the wall. So you're gonna do it? You're gonna check it real quick? Okay, and what I'm gonna do is I'm gonna go and you guys are gonna be studying the keys. They're all there on Google Classroom. What else? There's going to be AP Physics questions that have 2 answers on the multiple choice. Sorry, it's a gift. There'll be things with just a variable to answer with. Now the AP don't do a whole lot of projectile motion because they wait until you guys have the energy equations, okay, dynamics, and then all of a sudden projectile motion and momentum come into play, and so they mix a mixed problem. There's not a whole lot we can mix right now here.
Yeah, I was about like something on the quiz.
Which okay.
I was looking at it was like the one with the spy and she can shoot her dart at the angle of 65.
Oh, you want me to do that one?
Well, I don't think there's any math involved. I was just wondering because that's right. Like, do we
Let
have
me-
to find an, like,
Yeah, let me
same
bring up the
people?
question.
Yeah, so we know
Figure out something
one
for
that
the
exceeds the
site.
45 meter for one angle,
I don't
but
remember
the
if
same
it was
distance
on
for one angle.
homework.
It was a homework.
That one was like
Except for everything
super
besides
hard.
45, there's
We
2
can find
angles where it'll go.
Because that one's very
Oh, right.
Yeah. And then it's the same distance from like 90.
So we're talking about
Okay,
the
I
spy
think so.
question.
Yeah, I kind of. I understand it now, but.
Okay, a spy has to send a secret message using a special dart gun. She can shoot the dart at an angle of 67 degrees. Her enemies are getting closer. What other angle can she send the message, and what else must the pickup person know? And so what you can do is you subtract the 67 from 90, okay? And then, why did it do that? My computer did something silly. There we go. You need, so this is the 23 degrees, and then what else do you need to know? Do you change the velocity? No, you don't change the velocity. Remember I did the water in the sink? And I changed the angle? Okay, that's how you answer that question. So that's the monkey hunter type problem.
Is there gonna be a monkey hunter question?
I don't know. There might be. There might be a monkey hunter problem. There might be something like your lab where there's something going off. There might be a problem like this. So, Jeremy, did you figure it out?
Oh, whoops, I just messed it up. It's
No?
more.
What?
It's more.
So it is higher?
Yeah.
So it makes it. So 45 degrees works.
Yeah.
And then you can figure out how much further it goes down and all that.
Yeah.
That would be a fair question. Another fair question would be, you know, you're on the moon and you drop something and use other gravities, that type of thing. It's fair. Is there any other questions you guys want to ask?
Are we supposed to know the gravity on the moon?
Nope, I have to provide you that. Yeah, I have to provide all that. So this is going to just deal with projectile motion, okay? So it's going to be projectile motion, this test. Projectile motion and kinematics. I can bring something from last, so I can take an AP question or an AP release question and put it in there. If I use an AP question that they don't want me to send to you guys, I will take that part of the test and keep it. You won't get that back. Or you might not get the whole test back or something. You get the idea? But you can view your test to see what it's like. Okay?
Are we gonna have the same equation sheet with just the?
Same equation, yeah, like the AP. So all the conditions are the same, about a minute, 30 seconds per multiple choice and all that. We're gonna do all the same stuff. So what's gonna happen tonight is I'm gonna try to video edit this, and it'll probably be up by 8 o'clock, and I'll probably have a remake of your test. I'm trying to think of anything new to put on. What should I put new and exciting? Projectile motion. I could do an airplane. Oh, how about this? Airplane's flying. Okay, airplane's flying. Drops a box. What flight path will it take? Will it take this? Will it take this? Will it do this? Or will it do that? So let's say this is A, this is B, this is C, this is D. Maybe I better make C a different color so that people can see it. So here's an airplane, it's flying, it drops off a box. And so which flight path would it take? And so this goes from the kinematics video. You're walking around and you drop an object. Frames of reference and...
Frame of reference for that.
First of all, what is the Vx for this object? The initial velocity for the object.
The plane speed?
The plane speed. So Vx initial equals airplane or jet speed. Okay, it has the same velocity as the airplane. So does it land backwards?
No.
So that's the zilch. Does it land straight down?
No.
No, because it has velocity in that direction, so that doesn't work. So it has to be one of these two.
Are we including air resistance at all?
Nope. No air drag. Because these things are esoteric. So no air drag. So which one must it be?
D.
D? Yes.
Yeah, I just.
All objects fall in a parabolic motion. This is just half a parabola. Okay, so like going off the lab table and stuff like that, that's half a parabola. This is a partial parabola. The y0 f finals y final 0, that's a full parabola. Does that make sense? So as long as there's no air resistance. Yes, if this was air resistance, then this one becomes valid. Which is a good test question too. Hint. Good test question, hint.
Which one, this one?
Yeah, this is a good test question. I can change it up. What happens if there's air drag? Which flight path would be the best? Okay, I'm not going to have you calculate air drag. That's just mean. Okay, you're not ready for that. Let's see what else. So if an object is dropped on Mars, what flight path would it take? Dropped or thrown?
D.
What?
D.
D, it's always a parabola. Even on Jupiter, it's just going to be real quick.
Does Jupiter not have much of an atmosphere?
That has a huge atmosphere. We're just going to pretend it doesn't.
Oh, okay.
Because in physics, we pretend a lot. Everything is negligible, 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 because you're all beginners. And then when you get your calculus under your belt, then it doesn't become negligible, it is.